In this video, let us see how to automate the testing of your electronic board. To keep it short, we call it Device Under Test or DUT. Here, we are using two of our products. The first one is Automator Batch, which is our PC application software for defining test cases, for executing them in a sequence, and to generate test reports. And the next product is T7000P, which is our signal generation and acquisition hardware. Here is a preview of the automation. The inputs and outputs of DUT are exercised automatically based on the predefined test cases. At the end of execution, a test report is generated. In case you are new to our products, please visit our website for more details. Let us look at the high-level connection diagram of this demo. This is the electronic board, or DUT. In fact, we are using another T7000P board as the DUT for this video. This board is connected to the PC with Automator via USB. Let us say the requirement is to test some of the I/Os with actual loads, like servo motor, solenoid with limit switch feedback, and a few three-way rocker switches. The position of the servo motor is controlled using the pulse-out signal, PO1. The servo has a feedback voltage, which is dependent on its position. This feedback line is connected to AI1. The solenoid is powered from the system voltage of DUT. PO2 energizes or de-energizes the solenoid. The limit switch is wired such a way that DI1 goes high when solenoid is energized, and DI1 goes low when solenoid is de-energized. The position of the three-way rocker switches are captured using the digital input channels DI2, DI3, and DI4. Depending on the switch position, the DUT sees system voltage, ground, or open circuit voltage. And the remaining I/Os are tested using a T7000P. The pulse-in channels get signals from pulse-out channels. Likewise, the pulse-out signals are measured by the pulse-in channels. And the analog-out signals are measured by the differential analog-in channels. For ease of handling, these parts are all mounted on a single board. Here is the actual setup. This is the DUT. And this is T7000P. Both are connected to the PC using USB. Here is the servo motor. PO1 is connected to the servo, and AI1 is connected to position feedback line of the servo. This is the solenoid with limit switch for feedback. The solenoid is powered from the system voltage. PO2 is connected to the solenoid, and DI1 is connected to the limit switch. And these are the rocker switches. These switches are connected to the DI2, DI3, and DI4. And the remaining pulse outputs of the DUT are connected to the pulse inputs of the T7000P. The pulse inputs are connected to the pulse outputs of the T7000P. The analog outputs are connected to the analog inputs of the T7000P. Next, let us do the full automation using batch mode of the Automator. Here is the project with all the test cases to test the DUT. First, let us look into the test case for testing PI1. We have set up the test case to generate pulse output signals from P01 of T7000P with a few different frequencies and duty cycles. The PI1 of DUT measures these signals. The test case then checks if these measured values fall within predefined ranges specified in the evaluation criteria. All other pulse input test cases are very similar. Next, let us look into the analog output test cases. Here, pairs of analog output signals are tested together. For example, A01 of DUT is connected to AI1 plus of T7000P and A02 is connected to AI1 minus. So, AI1 of T7000P measures the differential voltage between A01 and A02. Like in the previous case, there is a tolerance specified in the evaluation criteria. The pulse-out signals of the DUT are measured using the pulse input channels of T7000P. So, these test cases are similar to the pulse input test cases explained earlier. Next is the test case for servo. This is the P01 signal that controls the servo motor position. The frequency of P01 is fixed at 50 Hz. For each commanded duty cycle, servo moves to a corresponding position. And we get a position feedback voltage on AI1 that we use to evaluate the test results. Next is the test case for solenoid. Duty cycle of P02 is set to 100% to energize the solenoid. And it is set to 0% to de-energize. The limit switch feedback reports the solenoid position via DI1. Next is the test case for digital inputs. As mentioned earlier, the DUT sees system voltage, ground, or open circuit voltage, depending on the position of rocker switches. Clearly, manual operation is needed to change the rocker switch positions. To facilitate this, we use what is called user prompts. User prompts are inserted in the test case tree and can be used to prompt the user for desired manual action. Here, the user can set a text message for pop-up dialog during the batch run, or can select an image to be displayed, or can do both. The image size within the pop-up dialog can be adjusted using these two parameters. For example, this user prompt prompts the user to put the rocker switches in one particular position. After this manual action is completed, the user needs to click OK to resume the batch run. In the subsequent test case, DI values are measured and compared against expected values. And this user prompt prompts the user to put the switches in another position. And the DI measurement and evaluation process is repeated. Let us run the test. Here, you can see the commanded duty cycle and the feedback graphs. The evaluation results are shown here. Here is the user prompt to change the position of the switches. Enter OK to resume the test after changing the position of the switches. Flip the switches and click OK again. Here is the test report generated with embedded graphs. Any anomaly in the functioning of the DUT is captured in the report. This completes the batch mode demo. Hope you enjoyed this video. Setting up an interactive system or a full automation system is very easy and affordable with our products. We do have plenty of other example videos on the usage of our products. Thank you for watching. For more information, please visit us at www.texarsystems.com or contact us through phone or email.